Hello everyone. We're going to continue off from where we left off a couple days ago. A couple days ago we ended off on lab 14 I mean. We finished up the lesson already, lesson 14 on if statements. So just kind of going through it real quick. Let me pull up the lab. This is where we left off at, lab number 14. We already finished the lesson associated with it over here. Lesson 14, right? We already finished this. If anything, the prerequisite for today is to make sure you understand the differences between the control flow. In particular, the differences between, if statements, chained if statements. What happens if you use like a if else, right? And then what happens if you use an else if in the middle, right? This is if you put an else if in the middle, it's gonna give a different tree. So yeah, that's pretty much the prerequisite today. If anything, we're going to finish the rest of lab 14 and also give a sneak peek into the next programming project. This next programming project is called Calculator. So yeah, stick around for this later piece. We're probably going to talk about this in like maybe half an hour, probably 20 minutes. And then I have some slides prepared for this project because this project is relatively dense. So I made a few slides that will kind of give some hints on how to do this project. All right, so stick around for that. Let's go ahead and finish the rest of the lab 14 though. Hopefully folks gave it a shot by themselves. If not, I would recommend pausing the video and trying it out. Let me reload this notebook. Okay, press play there, and then we bring these variables. Okay. Cool, so we ended off over on part number 3, where we were gonna write functions that contains branches in there. All right, so last class, I wrote a couple of test cases here that assume your function works. Right, in this case, get generation, if we pass it 1996, it should give us millennial. So same with 2000. 2000 should give us Gen Z, right? Because we're branching based off of these values. Let's go ahead and set up this function. So the function name is get generation. So define a function called get generation. Okay, and it does take an argument. The argument here is just an integer year, which represents the year the person was born in. And I'll go ahead and do a doc string. Let's see, the purpose of this is to convert a year to a generation. There's a single parameter. It's year, which is an integer that represents the year. And then the return value, we're just going to return a string that represents their generation. Okay, just setting up the doc string. For now, I'm going to do a dummy return statement, meaning, it's good programming practice to test often. So I'm going to do a dummy return statement and just return like testing. All right, the reason why is just so I can kind of catch errors earlier on. So there it is. I'll press play here, and then let me press play here. Hopefully it prints testing. Cool. All right, prints testing. We don't have any syntax errors in the function, nor the testing cell. Cool. Let's go ahead and finish this function now. So, we need to branch based off this year, right? Like based off of whatever number is passed in, we need to kind of make a decision. So there's a lot of different ways you can do this. Once again, I highly recommend trying it out yourself. if you don't try it out yourself, creativity can possibly be ruined, because you can go about this in different ways. Like you can represent it as a bunch of if statements, right? You can represent it as if statements with else ifs, right? You can represent it as this too, right? Yeah, so go ahead and try it out yourself. See what you can do. But for me, I'm gonna probably do a couple different solutions and see what folks think about it. So the point of this function is to return a string, right? Meaning that one way you can think about it is you can have it like a result equal to like a string, right? Like I'm just gonna set it to an empty string for now, and then maybe something in between, right? There's gonna be like a decision tree in between, and then the decision tree will kind of calculate the result for us, and then we'll finally return the result. Right, that's the goal right here. Basically, in between, we need to branch into different scenarios. Right, so one way you can say is, you know, if year is millennial, right? So how do we represent if year is millennial? Well, you know, one way you can do it is by kind of representing it as two conditions, right? You could say kind of like this right here, right? Earlier we represented it as if birth year is between this. So I'm just gonna go ahead and copy those. So this is a condition, right? Just one way. It says if we are greater than this and less than this, then our result will be something. All right, so here I'm gonna say result is equal to baby boomer. Okay, cool. So this is a fork in the road. All right, let me test this real quick. So let me just make sure. Okay, so I got an error here. Hopefully people can kind of guess what's happening here. Right, let's scroll down. Let's actually, let me comment this out. I'll comment this second one out. Press play. Okay, cool. So we got an error somewhere right here. Let's investigate what's happening. See, it says name birth year is not defined. Something happened when I copy and pasted the code. Right, so it's saying this is not defined. Right, that kind of makes sense, right? This because the variable that we're working with is called year. So let me go ahead and fix this typo. There we go. Let's test it now. So press play and then test this. 1996 should print millennial, but it's not going to print millennial yet, right? Because we didn't implement that branch yet. We didn't implement the baby boomer branch, so let's test that. All right, let's say get generation. You're a baby boomer if you're in 1950. All right, so this should return baby boomer, and I'm going to print it. This should print baby boomer. All right, let's test it. So press play, bang, and yeah, cool. It prints baby boomer for the first one, and these next ones are printing empty strings. Let's go ahead and implement the rest of the branches. All right, so the next is pretty much, so you can scroll up, and there's this stuff here already. All right, there's generation X. So I'll go copy this, and then paste it here as another branch. All right, so if we're between these, then the result is something else. All right, result is generation X. All right. So let's go ahead and test this real quick. So get generation. You're in Gen X if 1970. Print. This should print Gen X. Okay, let me test it. Okay, it did not print Gen X. Interesting. Let's see why. Oh, it's probably because I didn't run the cell above here. Right, see how it says the number 9? And then here it says number 12. I didn't run them in the correct order. So let me reload this cell. Press play here. And okay, I got this same error, right? This same error is saying, oh, birth year is not defined. Once again, this is because I copied and pasted code, but I forgot to change the local variable here. There it is. So change it back to year. And let's test it again. Cool. And now we got Gen X. Perfect. We can probably just proceed with the rest of it. If anything, it might be more efficient to combine these two conditions, two branches. I mean, basically, this is a little not efficient. It doesn't look like it, but it's not really that efficient because both conditions are being checked. For example, here when we have 1970. Or actually, no, let's look at this first one, right? With 1950, 1950 is going to get passed up into a function, right? So year becomes 1950, but then the function will say, hey, is this true? Right? This is true. meaning we're gonna overwrite result. But then the function is going to go down to this one and check this, right? There's no need to check this. Does that make sense, right? Because if the earlier one is true, there's really no need to check this. Otherwise, it's kind of like a waste of computation. So these are called disconnected if statements. This is like here, right? This diagram here, right? We're chaining conditions, and it's a little less efficient. So if you were to combine them using like else ifs right here, it's a little more efficient, because if an earlier one is true, then the next ones won't be checked. So I'm gonna go ahead and connect it. So this is now an elif, else if, right? The effect of this is if an earlier one is true, the next ones won't be checked at all, right? So with 1950, this is true, so it's going to immediately do the body of it and then exit the branch, right? It's not going to check this next one because it doesn't need to. Okay, so yeah, hopefully people see why I connected them. Okay, I'm going to go ahead and get the rest of this done now. So the rest of these are millennial. So millennials right here, you paste this. Else if this, and then result is equal to a millennial, and then finally Gen Z. Okay, let me remove this, and result equals Gen Z. Okay, let's go ahead and test this. So press play, and cool. Let me comment these out. Let's test it. Baby boomer, Gen X, millennial, Gen Z. Perfect. So we have 4 test cases. It passed all 4. We're good. Our function is good. Okay, any questions about this? Okay, cool. So this is just one way of doing it. There's actually an infinite amount of ways on solving this or representing the same solution. Infinite ways. I'm gonna do probably a couple different ways, right? Just so folks are aware. And I'm gonna purposely invoke some logical errors. Right? Logical errors mean that the code does run, but it gives us the wrong result. All right, so let me invoke some common pitfalls. I'm going to copy and paste this function and do it in a different style. All right, this is a different style. So here it is. I just copied and pasted it. I have a duplicate function right here. All right, let's go ahead and talk about this. So this current approach starts off with an empty result and then a tree that reassigns the result. It's actually not necessary to do this. You can actually just get rid of result, right? Get rid of result and do something called a premature termination, a premature return, right? Meaning that like right here, right? This is no longer valid, by the way, right? If I were to try to run this, Python is going to say, oh, I don't know what result is, right? Which makes sense because I just deleted the result variable. Actually, no, this will work, but but then it's gonna complain here. All right, so here's what I mean. This is actually a pretty big takeaway. Something called scopes. All right, so we're actually gonna get something called a scoping error here. So let's talk about what a scoping error here is. Here, let me comment these out. Okay, so I'm just gonna test it with one invocation and press play. Okay, hold up. This should have got an error. Oh, I didn't even run this function above, did I? Yeah, let me rerun this. Oh, hold up. I should have gotten an error here. Why am I not getting an error? I'm trying to get a scoping error. Maybe I need to reset something. I'm gonna go ahead and reset the kernel. The reason why is probably because I have like a leftover variable called result in the kernel. So let me reset this real quick. Reset, clear. Okay. Let me run this first cell up here and then scroll back down. Okay, so check it out. I'm trying to invoke an error here. It's a pretty good takeaway. So I'll go ahead and load this function in and then press play here. Oh damn, it still prints baby boomer. Interesting. Interesting. Okay, I might be getting confused with a different language. So yeah, my bad. Okay, let's talk about a different, something called an early termination. My bad earlier, I was getting confused with a different language. Okay, you know, instead of reassigning things, you can actually just return right away. This is called an early termination. So you can say return here, return here, return here. Right, only one of these returns will happen, by the way. All right, and then down here, maybe this is like the last resort, right? It's like an else. If none of these happen, then this is gonna happen. So you could return something like not implemented yet. Not implemented. All right, yeah, you'll see why I did this in a bit. So here, let's kind of trace what's happening here. All right, so get generation 1950. 1950 is going to go into the function. This is going to become true. So there's going to be a premature termination, meaning the function is going to end right here. Right, it's going to return baby boomer back down to the caller. Right, meaning that none of these things will happen at all. So let's test it. All right, see, it does the same exact thing, baby boomer. And then for the rest of these, right, see, same thing, Gen X, Millennial, Gen Z. Right, the reason why this is a different approach is because you can kind of, you can disconnect them and it'll still be efficient, right? You can disconnect them, make them else ifs, I mean, right? And it's still gonna give you the same behavior, right? Because if an earlier one is true, then the next ones won't happen at all. Right, does that make sense? Return. This is a early return. Okay, so let's test this. Press play, press play. Okay, cool, there we go. And the reason why I return not implemented is just for other numbers that aren't implemented yet. Like let's say get generation, let's say 1990, right? Let's say you're born in 1900, I mean. 1900. What generation is 1900? It's not implemented yet. Right, it's kind of like a placeholder. So hopefully people will see what's happening here. Okay. Okay, cool. Let's move on. Let's do one more and then go on to the assignment hints. All right, this next one is asking us to convert a string, I mean a integer, a number, I mean, convert some sort of number to a string. For example, if we were to pass in 98 to this function, it should evaluate to A. Right, if we pass in 85, it should evaluate to B. So let's go ahead and get that. Let's go ahead and define a function called grade letter percent. Okay, it's gonna take a argument. In this case, it's called percent. Okay, and then let me go ahead and get the doc string. The purpose is to convert a percentage to a letter grade. Okay. There's only one argument. Percent, which is probably some sort of number, right? In particular, probably like a float, right? The reason why I decided to choose a float is because, you know, you can have decimals in your grade letter. I mean, your percentage. Like, so it's a float that represents the grade. Okay, and then there is a return statement. We're expected to return the letter grade. right, as a string. Okay, cool. So once again, for now, I'm actually going to do a dummy return statement. This is typically how you start functions out, right? It's kind of like building a skeleton, right? When you're building things, you typically build the skeleton and then put it together later, right? So I'm gonna do a dummy return statement here and just return like not implemented yet. All right, it's just a skeleton. So let me press play and press play here, and cool. It's like a testing, right? Just making sure. Okay, so now all we need to do is branch off this number, right? We need to make some, what's it called? Some branches, right? So one way you could do is you could say if percent, right? If percent is within a certain range, then you can just return A. All right, so check this out. This is actually some pretty cool stuff. You know how earlier we represented conditions with two bounds? Like in this condition, we represented two bounds, right? Like the lower bound and then the upper bound, right? There's actually a nice shortcut you can do. You can actually just represent one bound, right? So you don't have to say if percent is greater than or equal to 90 and something, right? You don't have to say this and something. You can actually just return immediately from here, right? Because if your percent is greater than 90, then you have an A. Does that make sense? So you can just return an A right here. So let's test this. All right, let's see. So I'm gonna load this function in, and then go boom. Right, see, it prints A, right? Because 98 is greater than 90, so return A. Okay, let's go ahead and get B. All right, so can we do the same with B? All right, can we say if percent is greater than or equal to 80, return B? All right, let's think about this. Let's think about it. All right, if I were to test it right here, right, 85 go into here. All right, so is this true? No, it's not. So we're not going to return A. Is this true? Yes, it is. 85 is greater than 80, so we should return B. All right, let's test it. Cool, prints B. Pretty cool, right? And we can just, you know, do this for the rest of them. So percent is greater than or equal to 70. Return C. And then if percent is greater than or equal to 60, that's a D. And then finally, you can just return F. Actually, you don't need to make a condition to return F, because if we reach this last return statement, it's probably guaranteed to be an F anyways. You know what I mean? Because if none of these were true, then that means we're lower than 60. Right, we're lower than 60, meaning that F is inevitable. So, yeah, it should work, right? If you could go ahead and test this if you want. All right, I'm just gonna test one more. Letter percent. Let's test like 20. Right, 20 should print F, right? Which makes sense because, you know, none of these are true. All right, people cool with this so far? Okay, cool. I do want to point out some possible logical errors that may happen, right? The order of these statements actually kind of do matter because we were looking at one bound, right? Each of these conditions are looking at the left lower bound. If I were to change the order of these, what do you think would happen? All right, so here I'm gonna see this thing I highlighted. I'm gonna flip it upside down, right? Meaning I'm gonna check for the D, then C, and B and A. All right, let's see what do you think is gonna happen? So I'm flipping it upside down. Oops, made a syntax error here. Okay, let me copy this. C. And then fix this indentation. Okay, what do you think is going to happen? Right, all I did was flip it upside down. Right, it's the same conditions, but we're asking it in a different order. All right, what do you think is going to happen? So let's see. Let's test it with this first one over here. Okay, so 98. All right, if I were to test it with 98, it should print A. right? But what is it going to give us? It gives us D, right? Why? Right, because 98 goes into the function as percent, right? Is 98 greater than 60? Yes, it is. It is greater than 60, so we're going to prematurely terminate and return D to the testing cell. All right, so people see the logical error here, right? The logical error here is because we had the early returns in the incorrect order. Okay, so let me bring this back to the correct order. Hopefully that makes sense. Okay. A, B, C, and then D over here. Clean this up. All right, we should be back to normal now. Okay, cool. A, B, F. Looks good. Looking good. Any questions so far? Okay, sounds good. Sounds good. Let's move on. Let's see. There's one more down here. I'm not gonna do this one. You can try this out on yourself if you want. This is really the same thing as above, right? It's just gonna be a little more fine-grained, meaning that it's gonna ask you to include plus and minus into your what's it called? Strings. If anything, I will help folks out with probably a couple of branches, because this question has potential to learn about something called nesting. Nesting means you can have if statements within if statements. So check this out. Check it out, right? The goal of this function is to be more fine-grained. Let me make this editable. Meaning that if I were to invoke the function grade letter plus, right, and pass it in like some number like 99, apparently, according to this example, 99 is considered an A plus. All right, with our current implementation up here, it doesn't really factor in the pluses and minus. So that's kind of the goal here. All right, this should print A plus, right? And then additionally, if I were to test it with another one like 97, this should just print A, right? Because according to this example, 97 is not considered an A plus. Okay, so let's go ahead and get this function ready. So define a function plus takes a percent, and I'm just gonna put a docstring here. It's actually the same docstring. It's the same as above. Let me go ahead and copy it. Convert a percentage to a letter, and you know what? The logic is actually the same. So check this out. Check it out. Logic is the same. We just have to add a couple more branches, right? Or not a couple. Probably more than that. Cool. So all I really did was copy and paste the function from above, and change the name here. All right. Let's see the current state of the program. So I'll run it. Run the testing cell. It prints A for both. We need the first one to print A plus. So how do we do that? Right. Well, you could write a separate if statement here. Right. Well, you could, but it might look a little ugly, right? Like, can you imagine how long this function would get? You could say if percent is greater than or equal to 99, then something something, and then you can say, let me change this to something. Return A plus, right? And then you could do it for the other ones, right? But I would recommend kind of, I want to introduce something called nesting, meaning that you can have if statements within if statements. Basically, I'm trying to have folks visualize something. I'm trying to have folks visualize trees within trees, right? So last week we talked about kind of just like single dimension not single dimension, more like trees that don't really have big branches, right? Like this tree right here, it's pretty small, but you can make more complex things, right? Like you see how this branch has a tree, and then the smaller branch has another tree, right? This is called nesting, right? Meaning you can have things within things. So that's kind of what I want to bring up here. So inside of this A case, right, we could actually nest another if statement in here. Right, we could say something like if the percent, right? Take note of this what's it called? This indent, right? I did indent it, meaning that this is now inside of the first branch. So I could say if percent is greater than equal to 99, then this is an A plus. Return A plus. Right, and then what about the A minus? Right, A minus, let's see, what's considered an A minus? It says an A minus grade, like 90. Okay, so I guess 90 is considered an A minus. Interesting. I thought 91 would be considered it. Okay, whatever. It's up to this question here. So you could say if we have 90%. Yeah, I guess we could do that. Let's not focus about the rounding stuff. I'm thinking too far, but if you want to be more accurate, you could do some rounding functions and stuff. But for now, you could keep it simple and say something like if percent is equal to 90, that this is apparently a minus. All right, so people kind of seeing what I did here, right? This is indented. All right, so you can imagine this as a branch that contains kind of another tree. So let's go ahead and run this. Right, so I'll press play and then run this over here. And finally it prints A plus, right? The reason why is because 99, right, goes into here. Right, so this big branch is true. All right, now we're going to check the smaller branches. Right, is this true? Yes, it is true. So we're going to return A plus and terminate the function here. All right, pretty cool, right? And let's test it with more. A grade letter plus 90. This should print A minus. And yeah, perfect, right? Because 90, this big branch is true. So we go into the inner ones. Right, the inner ones is here, and this one ends up being true. So we return A minus. All right, people cool with this? People kind of getting a sense on how this diagram represents like something called nested if statements. Right, you can have trees within trees. Okay, you don't have to do it this way, by the way. you don't have to, but I'm doing it this way just to introduce something called nesting. So this is called nested if statements. Right, it's some useful stuff. It's very useful stuff. I showed some of this stuff last week, like the COVID. Right, this is a nested if statements. Credit card analysis. This is nested as well. And yeah, a lot of things are nested logically. Okay. With this, hopefully people are able to complete the rest of it. It might be a little tedious, but yeah, you'll get a lot out of it. Okay, so that's about it for this lab. Let's see. Well, with this in mind, we have enough to go to the project. Project 14 on the calculator. Okay, I'm gonna first download the notebook and then skim over it, and then after that I'll pull up some slides that will help us understand the problem a bit more. I have a few slides that kind of explain what's going on. It's a pretty dense assignment. Okay, so the project here, assignments, It's called calculator. Let me go ahead and download it and then upload it. Week 10 calculator. Upload. Oh, it looks like I already downloaded it before because there's like a suffix 1 here. Let me remove this suffix. Okay, cool. All right. Let's skim through this notebook first. Right, there's actually quite a lot going on. Hopefully it'll make sense by the end of today. Cool. So here's our notebook. The point of this project is kind of to practice if statements. In particular, the whole goal is to write a function called doCalc. And this function is meant to calculate different types of operations. Right, so just talking about operations real quick. I kind of want to formalize some terminology. Right, so just formalizing some terminology. You know, if you have this math equation, right, 1 plus 4, we have a left operand and then a right operand, and then the operation. Right, so I'm just gonna formalize these terms real quick because I'm gonna be using these words a lot. Okay. Cool. This function is going to take 5 arguments. Right, it does seem like a lot. But pretty much these arguments are representing the equation, right? Meaning that you can think of A plus B, right? This is A plus B, right? This plus is the operation. This op right here. This last argument. So here, let me actually pretend like this function exists. And I think it'll make a lot more sense when you see this. Okay. Cool. So here's let me put my name here. There is this widget here. Please don't worry about this widget yet. It might make things look a little more confusing than it is. So yeah, do not worry about the widget. We're gonna invoke it manually. All right. So I'm gonna make a new cell down here. This cell is for local testing. Or not local testing, more like manual testing. Meaning we're planning on invoking our imaginary function up here. Right. So the point of this is to write a function called doCalc. Right. So here let's pretend it does exist. Right. Let's say doCalc. Okay, there it is. So I just invoked the function. It does take 5 arguments though. So the 5 arguments here are all strings. Right, you see all these highlighted things? They're all strings. See string. All right, so let me get these strings ready. All right, I'm gonna hard code in some empty strings for now and then fill it in. All right, so imagine we have this function. Basically, these strings describe the equation that the function should do. Meaning that if I were to put like 1 here and then treat 1 as an integer, right, and then put a 4 here but treat 4 as an integer, right, and then do an operation like a plus operation, right? So this is really saying, hey function, what is 1 plus 4? That's really what it's saying. So you know, this should evaluate to 5. Right, I should evaluate to 5 because we're adding integers. All right, hold up. So stay with me. I know this might seem like an overly complicated way of, you know, adding 2 numbers, but it'll make sense in a bit. Okay, so this should evaluate to 5. Meaning if we print it, right? If we print this evaluate, it should print. Right, should print 5. Okay, let's do another example real quick. Right, pretending that it does exist. So let me say doCalc again. And once again, it does take 5 strings. So I'm just setting it up. And let's pretend we're doing the same thing, right? Let's say we do 1, right? But let's pretend like we want to treat 1 as a string instead. Right? So I'm going to put like an str here, meaning we're treating 1 as a string, not a number. Okay, and then for this next one, say 4, right? And we want to treat, let's say for some reason we're treating 4 like a string. Okay, and the operation, let's say we're performing like a plus, right? This is saying what is 1 plus 4, but as a string, right? So string addition is different, right? This should evaluate to 1, 4. You know what I mean? Because when we're adding strings, it technically doesn't do math. It should glue the numbers next to each other. Right, so this, if we were to print it, all right, it should print 14. Right, so that's pretty much the goal of this function here. Right, so I do want to point out the differences between integer addition and string addition. Right, like here, let me pull up a REPL. Once again, a REPL is like a quick way on interacting with Python. So I'll pull it up real quick. So I type in Python in the terminal, and let's go back to like week 1 stuff. Right, so 1 plus 4, this gives us 5. Right, but what about 1 plus 4 as a string? Right, this gives us 1, 4. Right, so this is called string concatenation, right? Because we're treating them as strings, so we're not really doing math. We're gluing them next to each other. Right, same with hello plus world. Right, you can glue these together and it gives you hello world. Right, it's not really math. Okay, let's go back to the lesson. So, not lesson, the project. So people kind of seeing what's happening here, right? That's pretty much these arguments here. So you can read these. You can read this documentation later. You can read this stuff later. But yeah, it's pretty much all strings, right? That's pretty much what it is. Okay, any questions about this so far? Okay. Cool. So let's see. Let me think real quick. Int. Okay, let's talk about all the different operations that can possibly happen. There's quite a lot, actually. There's, you might have seen from chapter something, not chapter, the lesson 4. These are operations, right? We got like a plus sign, a minus sign, division, times, right, all the way up to here. These last 5 are Boolean operators, right? They don't really do math. They give us like a true or false result. So yeah, there's a lot of operations that we should implement. That's why the assignment is a little dense, right? Because there's multiple of these. So in particular, all you really have to implement are these. It's like 6 of them. Let me see. Just the plus sign, minus, multiplication, division, and then a few Boolean operators. Right. So these first 4 are mathematical operations, and then these later 4 are Boolean operations. Meaning that, if I were to test it again, right? Like let's say let's say I were to invoke the function again with a Boolean operation. Like let's say, so these are all strings, right? 5 of them. Let's say I were to do like 4, treat this as an integer, and then maybe 6 for some reason, treat this like an integer as well. And then if we were to use the less than operation, this is saying, hey, is the integer 4 less than the integer 6? Yes, it is. So this should evaluate to true. I should evaluate to the Boolean true. meaning that if we were to print it, it should print true. All right, people see what I mean? We're writing a calculator that can work with multiple operations. All right, let me pull up some slides real quick to kind of put this a little more together. Okay. All right. One of the biggest goals in this calculator is to practice nesting. Right? Nesting means that we can have if statements within if statements. It's actually possible to do this calculator project without nesting, but you'll actually get a lot more if you do nesting, right? Meaning if statements within if statements. I'll do an example of this in a bit. Okay, so you've seen this terminology before, right? Operand and operation. This is stuff that you'll see in the project, right? So in the project over here, the arguments, right? It says the first argument is an operand, and then the second argument describes the type of it, right? And B is an operand as well, and then the last one, this is the operation to perform. So that's the arguments are pretty much just talking about this over here. Cool. So once again, operand in this case, this is string concatenation, meaning we're gluing strings together, right? And we can have Boolean operations as well, right? This one should evaluate to true, right? It doesn't evaluate to a number, just true, because 1 is less than 4. And then similarly, this is also a Boolean expression. We saw this a couple days ago. The keyword in is a searching operation, right? In this case, it's searching to see if Drew exists inside of this other string, right? So this is a Boolean expression that returns true because there is a Drew over here. Okay, the tricky part of this assignment is representing a decision tree in the function. There are about 8 operations that we're required to implement here. Four of them are what's it called? Mathematical operations, right? That can evaluate certain math stuff, and then these other 4 represent Boolean operations, meaning it should return to true or false. So yeah, this is the tricky part of the assignment. And actually, I didn't even talk about the nesting yet. This actually doesn't look nested, but it should be nested though. So here, let's look at the left. So you see this plus sign? Basically, if we perform the addition operation, it should lead to a bunch of cases, right? Like what kind of plus are we doing, right? Are we doing integer addition, or are we doing string addition, right? So once again here, let me modify the slides real quick. I'm just going to change this real quick. Okay. Okay. Cool. So I was back at saying this plus sign, right, on the very left. How do we add things? Well, it depends on what type of operands they are, right? For example, if we're adding integers, this will give us a different result than adding strings. Does that make sense? Right? Well, what's the difference between these two results? Right? Well, this one gives us 5. This one gives us 1, 4. So this means that there's going to be a nested tree underneath this plus sign. Right? So I couldn't fit it on this screen. This decision tree ends up being pretty large, actually. If I had a whiteboard in class, I'd be able to represent this a little better. But I had to do another slide that represents this plus sign. So let me go to the next slide. It's going to represent the nesting over here. Okay. Cool. So the operation right here on the top right, you see how there's kind of like a nested tree under here, right? Well, we're ignoring all the other operations, just looking at the plus sign. The plus sign depends on what we're adding together, right? Integer addition is different than string addition, right? And then, you know, same with floats, right? Floats are different from string additions as well. So depending on the operand type, we have to branch off into different scenarios, right? So yeah, people kind of seeing this nesting that I'm talking about right here, right? See, here's the operation. If it's a plus sign, then we're gonna go to the plus sign and check what type of plus to do. So that's kind of what the project is over here, right? Like right over here when we call the function, right? These let me comment this out. Right, these two functions are different. Right. Okay. So here, let's make things a little more concrete. It should make a little more sense when I help folks out with a couple branches at least. So the goal is to define a function called doCalc. Okay. It does take 5 arguments. The 5 arguments you can check up here. All right, so A type, B type, op. These are all strings. Okay. The purpose of this function is to perform a calculation. Perform a calculation given. I'm just gonna keep it simple. You can interpret this however you want. But yeah, all it does is perform a calculation. There's a bunch of arguments. Let's see. There's the argument A. They're all strings, right? This is a string that represents the left operand. All right, once again, the operand is like this thing right here, right? The operand is the value to the left of the operation. So A represents the left operand. A type, it represents the type, right? The type of the left operand, right? Because we could do different things. And then same with here, right? B. I'm just gonna copy and paste B and B type actually. It's the same thing. It's literally the same thing. It's just that it's the right side instead. So B type. And then finally the operation. This is also a string. It's a string. It represents the operation to do. Okay, and there's just one return value. Returns the result. Okay. Hopefully people are getting a sense on what we're doing here. All right. Let's see. I'm gonna do a dummy return statement, right? Because I'm gonna build a skeleton, meaning just return something, return a placeholder for now. I'll just say return not implemented yet. Right, just a little placeholder, meaning that these should print not implemented yet. Okay, cool. Yeah, print's not implemented yet. This is a good sign. It's a good sign because we didn't get any errors. We don't have any typos. Okay, so let's kind of focus in on the plus sign branch. This is one of the things we have to do. All right, we gotta represent a branch that goes off the operation. So let's do that. Right, a branch, you can think of it as an if statement. So, you know, in this function, you can say something like, if the op is equal, right, double equals, by the way, right, you need double equals because it compares. You can say, hey, if the operation is a plus sign, then we can do something here, right? So let me do something that's incorrect and then fix it later. Right? So if the operation is a plus sign, this means we need to add the two A and B. Right? So we could just say, hey, return A plus B. Does that make sense? Because then it's just going to return the result from these two sum. All right, so here let's test this real quick. I'm going to test this very first function invocation. All right, let's see what it does. So I'll press play here. All right, it prints 14. Right, it shouldn't have printed 14. Does that make sense? It should have printed 5. Right? The reason why I printed 1, 4 is because we're technically doing string addition right here. Right? We're doing string addition because all of these arguments are strings. So we can't just return A plus B like this. Right? We got to kind of do another branch. Right? So this is the diagram that I was pulling up here. Right? Basically, if it's a plus sign, then we need to branch and check the types of operand. Right? We need to check the A type and the B type. Right? So maybe you could say, hey, if A type is an integer and B type is also an integer, then we should convert those strings to an integer. Does that make sense? So we could do something called nesting. Right? Nesting means we have if statements within if statements. So in this case, I could check the types. Right? We could say, hey, if the A type and the B type are integers, then we should convert the A and B to an integer. Right? You can do that pretty easily just by kind of wrapping the value inside of this int keyword. So that's pretty much like saying, you can pretty much say int A plus int B. Right? A and B are strings, but these converted to integers, meaning that it's going to do the math. All right, and this is a floating number. It does do something, but we should probably do something with it, like return it. Right? Return it means to give it back to whoever called it. Right? In this case, the testing cell is calling it. Okay, so let's test this right now. So let me press play here and press play here. Okay, it says not implemented yet. So I have a, this is actually kind of tricky to see. Can people spot the error? It's actually tricky. It's actually a tricky thing. I made a small typo. So this should have happened right here. Right, but it didn't. Right, it didn't, and we ended up with not implemented yet. So let's kind of trace what's happening. So here we passed it up. They're both integers, int, as the A type and B type. They get passed up into here. And then down here, right, is this true? Is A type equal to int? Yes, it is. Right, because see, this is the A type down here in the testing cell. This is the A type. But B type, right, is this true? It's actually not true. I accidentally hard-coded this left side to be a string. Right, you see what I mean? So this is never true. I accidentally hard-coded a false condition here, meaning that this will never happen. Right, I meant to use the value of B type. So go ahead and remove those quotes. Right, and now it should become true. Okay, so I'll press play here, and there we go. Right, it finally prints 5. Okay, so let's trace what's happening. Right, just kind of focus in on these ints right here. Right, these are the A type and B type. Right, these two get passed up into these arguments. Operation is equal to plus sign because we did pass a plus sign. Right, this does become true, so we end up converting the strings to integers and kind of just returning the sum. All right, people cool with this? Cool. So let's test it again with this next one. So this next one is doing the same thing, but it's treating them as strings. So let's see what happens. All right, so I'll press play here, and it says not implemented yet. All right, that not implemented yet, meaning, yeah, it's landing here. All right, so let's trace what's happening. So is operation plus for this one, for this second one, is operation plus? Yes, it is, because we passed in the plus sign, right? Is this true? No, it's not, because the A type and B type are both strings. All right, so we don't return the A plus B. Instead, we exit the branch and do this right here. So this means we need to implement a branch, a sub-branch for the strings. Right, so you can think of this, it's gonna look tricky from here, actually. Keep in mind of these indents. It should make sense in a bit. So here I'm gonna implement a sub-branch for this plus sign. Right, basically we need to implement the strings here. Right, if they're both strings, right, if they're both strings, do we need to do anything? Not really, actually. We don't need to do anything because conversions, I mean. All right, A and B are already strings, so we don't really need to convert them. All right, all we need to do is just return the sum of them, right? Because these are already strings, so it's gonna automatically do string concatenation for us. So let's test it. Press play, and then press play here, and yeah, there we go. We finally get 14 for the second one. Right, people cool with this so far? Okay, cool. All right, so all we did so far was this right here, right? We represented a big branch for the plus sign, and then kind of zoomed in a bit and implemented the small branches for integers and strings. All right, that's all we did so far. Let's go ahead and talk about other operations, like maybe the minus sign, or actually let's talk about a Boolean operation. Let's talk about like maybe the less than. All right, the less than operator. So this is a big branch, right? It's like the upper level branch, meaning that we need to keep in mind of the indents, right? Like how would we check if the operator is a less than here? Right, see, you see this third evaluation, this third invocation, I mean. Right, how would we check if the operator is a less than? Well, you know, it wouldn't go here, right? Some people might say, oh, if operation is equal to less than, right? You might do this. This is actually a logical error. This is actually never going to happen. Due to the indents. Let's see. Due to the indents, this if statement technically belongs in this big branch, right? So this is actually impossible, right? Because if our operation is plus, then this is never going to be true, right? But people see what I'm saying. So I'm trying to say that this is not supposed to be indented, right? Because we're on another layer of the tree. So yeah, if our operation is less, then you can pretty much do the same stuff here. All right, people cool with that. So I'll leave this as to do here, and you can imagine the other ones too, right? Like if operation is equal to something else, right? Pretty much the other operators over here. So yeah, I would recommend testing this frequently, and keep in mind of the indents. Hopefully people see what I mean here. So here, let me just summarize what we did so far. So this highlighted piece, this is kind of representing this over here. All right, let me kind of zoom out a bit. Let me zoom out. I'm gonna copy this over. copy and then paste. Whoops. Copy and then paste. Okay. Okay, I couldn't fit it, but this is really what we coded so far. All right, we have the operation that's equal to plus, and then we checked the A type and B type, and then we programmed this int and the string. All right, that's what this is representing over here. This highlighted piece. All right, people cool with this? So yeah, hopefully people will see why this assignment might be a little dense. It's because there's a lot of different little branches. Okay, cool. Hopefully people are okay with that. Finally, there's a widget. All this widget does is call the function for us. That's really all it does. So I'm gonna go ahead and play this widget here. All right, so there's 5 widgets here. These are just representing the arguments to the function. So if I were to do like 1 plus 1, 1 plus 4, and treat them like integers, right? This is literally the same as this over here. It's just calling the function for us. So 1 plus 4 as integers, this gives us 5 right here. Right? See, that looks good. And if I were to change them to strings, changing both these strings, it gives us 14. All right, this is literally the second line here. Okay, cool. Hope that makes sense for folks. That's about it for today. I hope this gives folks a good head start on the calculator. It might seem tedious, but you're probably going to get a lot out of it. In particular, you're going to have a lot of practice implementing nested decision trees. Some good stuff. Okay, that's about it for today. So let's summarize what we did. Whoops, did not mean to do that. Let me go to where do I'm going? Oh yeah, I'm going to syllabus. Okay, weekly schedule. So we finished decisions, if statements, logic. Next week we're gonna talk about some loops. We're finally going to be able to run statements over and over again without having to, copy and paste it. So stick around for that. The tricky part of the class comes in the loop algorithms. So yeah, that's about it for today, folks. Thank you. Have a good day.